Hello everyone,
Hi.
and welcome to this 217 live stream. Let's jump in. So we have a small presentation as usual. The first announcement we'd like to make is that we'll be at SIGGRAPH 2023 this August in Los Angeles. So we will be on the French pavilion booth, Cap Digital. If you need to know the booth number, we'll be posting it on Discord pretty soon. So if you're around, come and see us. We'll be happy to showcase the latest 217 and discuss roadmap or anything you'd like to know. So in the live stream, we'll go over a quick update on the versions we support. I'll show some updates on the plugins in the presentation, and then a small demo where we will showcase new features on the GPU sim side, runtime and editor templates stuff. So 2.15 long-term support is still under development. The next patch, the 11th one, will be released in a couple of weeks approximately. So we will continue bug fixing and do any additional changes required as planned. All right, so yeah, increasing the sound because apparently it's a bit too low. Sorry. Yeah. Okay. Let me know if I need to increase a bit. So 2.15 development is continuing as planned. 2.16, however, we plan to do a last patch in the next 2 weeks. Of course, if there are any critical issues, we'll fix them, but we will try to close 2.16 development in the next 2 weeks. 2.17 is a new release, which we'll go over today, so we plan on maintaining 2.15 and 2.17 mainly. Is it right? Yeah, small update on the documentation. So on PopcornFX website, if you know, probably there's a documentation. We added 3 pages on the debugging topic. We know we are lacking some features are basically undocumented, so we will work on that in the coming months to add, for example, like spatial layers or missing documentation pages. On the Unity side, we finally have support for audio particles. It's like the light particles we added recently. It's using a game object, a pool of game objects. So it's native Unity sources. It's not like Wise or Fmod Studio. It's Unity's built-in tools. You can also import a pkkg file as it's shown in that GIF here. So it's an additional way to import effects in the project. So the advantage of packages is that you can bundle a few effects actually in them or various kinds of resources. If you had an effect which exposed an orientation attribute, basically previously I don't believe it was exposed. Now it's displayed as Euler angles. Internally they are quaternions, but for the user experience it's displayed as Euler angles. You can also specify them via gameplay, of course. So 2.17.0 we added built-in teleport support. So what this means is that previously if you had an effect, an emitter at world origin, for example, and by gameplay you teleport it, you set the game object location at like 10,000 on the x-axis, what would happen, because PopcornFX runtime does not know that the teleport occurred this frame, and your effect being teleported contain a trail node spawning based on this distance, it would have created a massive trail of particles. It's a recurring issue. So now you can tell on the emitter, per emitter, that this emitter was teleported, so the emission should be cut off. A minor. We should increase the sound maybe again. Yeah, sorry. We're struggling with a new microphone. Trying to increase a bit. Oh yeah, okay. Maybe it's going to be a bit better this time. Right, so and yeah, so this did not make it into 17.0, but we have added also support for visibility. So only in Unity Editor, if you have a game object with a PopcornFX emitter on it, if you hit the eye icon in Unity Inspector, basically it just hides the emitter. Normally, it's a feature available at runtime too if you have gameplay that needs to do that. And the last thing is a timescale. So if your game has slow motion, you can specify per PKFX emitter a different delta. As Julien will show a bit later, we have added built-in support in the physics node, actually the collision node, a way to extract the surface properties, the surface type, I mean. The thing is, O3DE physics materials does not have any notion of surface types. So we added a new command, print PopcornFX physics surface type constants, which basically lists all of the physics material assets in the project and prints a unique ID for it that you can specify in the project settings on PopcornFX editor side. Once this is done, you can then use, as Julian will show, the surface type switch and logic and do what you need with it. So on Unreal Engine side, it's the same. However, Unreal Engine has built-in support for surface types. So basically, if a particle collides with a material, I mean, an object which has a material itself having a physical material with a specified surface type, well, it's extracted correctly, as long as it is specified in the project settings too. And yeah, last thing on the Unreal Engine side, we have added a new column, actually new columns in the top offenders profiler, where it displays so GPU side timings and the relative time of the GPU time. Doing that, we realized that the GPU timings for D3, D12 backend specifically have been off quite some time now, so we will fix it pretty soon. And that's it for the presentation. So is it the sound a bit better now, hopefully? Let us know in the comments. So I will show some new additions done on the GPU sim side. The first thing being that we have added support to for skeletal mesh sampling, basically. So if you have a mesh attribute sampler in PopcornFX editor and you bind it to the mesh backdrop, now it works for GPU particles. This is a unit test effect, but the green particles here are GPU particles and the blue ones are CPU. You can see this gets evaluated on GPU, it just works. Yeah. Yeah, so this is only in PopcornFX editor. For example, if you want to use that in real Unreal Engine plugin, we have to implement that in the plugin too, because yeah. It's a nice way to visualize an effect in the editor. So on the road to add GPU events, we have added a first step, which is extracting payload on the GPU side. So here I have two examples. The first one on the left, it's a fountain of particles. Yeah, lots of awkward sounds today. So this is a case where it did work prior to this version, which was a basic event multiplier with just a fountain of particles. And the local position toward and local direction toward here, we're basically using the effect instance position and orientation to be properly transformed. So that was a case that was correctly handled. However, this case, I wrote KO, was not working. So it's the fountain on the right. If you had a trail, basically each particle emitting child particles need to Yeah, no, sorry, let me say that. So if the parent particles had the position, color, for example, which is it's built in for it's mandatory, I mean, for the train node, it requires in the child node to extract the payload. So if you had a train node basically, and the child layer was GPU, what happened is that the spawn part was executed on CPU. It was executed on CPU and everything was transferred to GPU. Long story short, now it works. So local position to world handles correctly extracting the position or orientation from the FX instance or from the parent particle payload if there are any, and you can extract any payload that you have appended. So that's the first step. Then we need to address that, and that will be looked into in the coming versions to make that node trail executed on GPU. So it's a nice improvement. So I will not showcase that, but basically if you had a box, cone or sphere shape, it's a primitive, so not a 3D mesh, the shape contains intersect or intersect p-chords, project p-chords, sample distance field functions were not available on GPU. Actually, we did implement them a while ago, but at some point they stopped working, so we have them all fixed now. There is going to be an additional round of fixes in 2.17.1 next week to address some cases, but now it works correctly. Another feature, so if you do not know what sample density means, basically here we have an example of like a grid of 1,000 particles spawned, sampling an image, and you can see that the distribution is completely random. There's a feature in Popcorn to sample a density map, so particles are directly sampling the color information of a map that is specified, and now that works on the GPU. So as a reminder, hot reload does work in the editor. So if I say, you can see that the gray area is the white area is brighter, so more particles are spawned on the white area than on the gray area. So that works. The remap density basically takes UVs as inputs and remaps them using a density map. So those two are working currently. If you are using those features, but for Atlas, with an Atlas of texture, it's not yet implemented. It will be soon. And yeah, so last thing on my end, we did some improvements on the performance of spatial layers. So if you followed the previous live stream, you might recall we mentioned some really big performance improvements for the sort algorithm we use, but it was only changes that impacted the rendering of PopcornFX editor. We ported those changes to the spatial layers code, and now basically the insertion step of the spatial layers for GPU particles has been increased by, reduced by
divided by 10.
Yeah, divided by 10. So we have additional IDs for the query part because it's a multi-step algorithm, but it's a nice improvement too. That's all for me. We'll let Julian talk up.
Thank you, Hugo. So on my side, I'll show you the new features on the runtime and simulation side. Then I will jump onto the editor-specific features, and finally a few changes in the templates and core library. So regarding the simulation, first thing I'll show you is the new visibility helpers, which allow you to do basically frustum culling in the graph. So it's view.isVisible. You have three of these: isVisible point, sphere, and box. So here, if I drop a view is visible point, take the particle position as the position of the point to test. And then on those two renderers, if I show the enabled pin and wire the visibility result into that enabled pin, this will basically hide the renderers whenever the visibility test fails. So here, if I move the camera closer, you will see that on the edges of the screen, the lights are popping. So if I pause the simulation, yeah, here you can clearly see the effect of it. If I use the visible sphere, so it's the same, except it's taking a radius as input. So here I'll just use the light radius for this, and now there are no more artifacts, but it still performs the culling. And by the way, here it looks like it's overly conservative, but that's just because the radius of the lights are pretty huge. So yeah, it's kind of expected. If I go here, you can see that it does indeed do the culling as expected. So yeah, it can be some useful helpers. Not really useful to curl like per particle, to curl a sprite or whatever. That's not really the point of this. It would be kind of counterproductive. You don't want to do manual culling per particle just to not draw some billboards. It's more useful on the LOD side, or to avoid doing some more expensive computations when the particles are not visible. For example, if you do a scene intersect, or if you want to pipe in the enable collisions pin as a result of the visibility test, you can do that, and it will save performance quite significantly. So yeah, that's a useful new little tool. Speaking of visibility for boxes, we added a way to get the bounding box of shapes. So this was initially supposed to go into the shape properties node, and to have a boxmin and boxmax outputs, but we kind of messed up for this release, and the change was reverted. I think it's my fault, actually. Anyway, so you will have this in this template, but for the next version, for 2.18. Right now, you can still use the feature by using a script. So here inside this script, I will expose a boxmin and boxmax output, and here I can simply do boxmin equals the shape dot bounds min, and the same for the max, bounds max. And then I can simply pipe that into a debug draw box. So yeah, by default they're not shown, but the debug draw box also now has a boxmin and boxmax inputs conveniently. So I'll just wire that in there. Oh, it's paused. And because this is the local min and local max of the, well, the min and max of the local bounding box of the shape, here if I hover the actual shape, because it has a translation, you will see that it does not match the box. This is because you also need to wire in the position and orientation of the shape for the box to match. So now you can see that it matches. And if I translate the shape, you will see that the display of the box does not follow it. So this is actually normal, well, kind of, because the min and max functions get inlined by the graph compilation. And because they get inlined, and because we don't recompile the graph every time you translate the shape, it means that you need to hit the recompile button explicitly for the coordinates to update. So this is just an edition only problem. You won't have this problem in engine. If you have a shape that can change in engine, it means it's an attribute sampler, and it won't inline the calls, and the thing will properly update. So yeah, we'll probably fix this in a patch or something. Right now, it's kind of expected. So don't be surprised if you update your shape, like change the height or whatever, and you don't see the box update. You just need to click that compile button. So next up, actually I shouldn't have closed that. Hugo talked about the physics collision types. So yeah, in the physics node and in the collision node, you now have a new output, which is the collision surface type, which you can use in a custom check with surface physics.surface type, the physics.surface type node, which lists in the drop-down here all the surface types set up in your project, so you can check, is this some sand? And it outputs the true or false result. You can then use that in a custom logic, in a trigger. You can trigger only if it collides with whatever type of surface. And also, if you use the built-in event collide and output that, you will see that the surface type is now added automatically into the payload, so you can extract the surface type it has collided with in the child layers. So here, yeah, towards the end of the list, you can see the integer contact surface type. And so same thing in the child layer, you can extract that payload, compare it with a physics surface type node, and yeah, do your collision surface check.
This is a CPU only, right?
Yeah, this is a CPU only. Well, actually, if we dive in there, in the collision node, so these are the different collision primitives we have. So the scene collision is only CPU only. The shape collision doesn't have the notion of a surface type because it's just a shape. It's not part of the scene. And the depth collide, which is used for the GPU simulation, also has the surface type output, but right now in the editor, it's absolutely not implemented. But if you override that, because this is a simulation interface, so if you have a custom engine integration, you can implement that yourself. And if you want to support it on the GPU with the scene intersections, let's say you have a G buffer that contain object IDs or whatever, and you can somehow remap that to surface types, to collision surface types. You can implement that in your simulation interface, output the collision surface type. Here you can see that it's just a default pass-through with the default surface type, which is used when there is no surface types available. Anyway, so you can implement that in your engine if you want. But right now the editor is just, yeah, for the GPU collisions, depth buffer collisions, it just ignores it and outputs the default surface type. Thanks for asking. Right. So next up is a change that might be a bit of a corner case, but is actually pretty significant when you have infinite particles. So this effect here, you can see that, well, it's an infinite particle that uses the infinite life node. And when you stop the effect, the particle will animate and die off, and now no more particles. So this is because this infinite life node checks if the effect instance has been stopped. If it has, it goes on to some custom logic to kill the particle after the death delay input here, which is set to 2 seconds. If I set it to 0, you will see that the particle just dies instantly. And during those 2 seconds that it takes the particle to die, it will output a death-life ratio output, which will smoothly go from 0 to 1, just like the self-death-life ratio, and which is used in this effect to sample some fade-out curves, which give this animation. Anyway, if you were using the built-in set-life node with an infinite life, so not using the infinite life node, but using the regular set life node, before 2.17, it would behave like that, which means it would keep the particle and totally ignore the effect stop. And this is actually not a bug, it's by design. The set life does not do an effect stop check. You have other functions in the C++ SDK that allow you to explicitly kill an effect instance and kill all its particles, even the infinite ones, but the effect stop is something different. However, we've had quite a lot of support requests regarding some leakage in scenes or particles that memory that kept increasing or stuff like that. And it turned out to be every single time this issue, the set life with infinity without effect stop checks, and the effect instances were simply stopped, but had infinite particles. So after a few hours of gameplay, well, you would have a whole bunch of infinite particles still left in the scene that would do stuff. The performance would go down anyway. So now by default in 2.17, you have this infinite life check property in the set life node, which is checked by default. And this means that even if the particle is infinite, now by default you stop the effect instance, the particle will be killed. So what this changes in practice, it's actually a pretty small change. So before 2.17, these are the instructions of this layer, and with that enabled, it just adds a few more instructions to do the effect instance is running check. And this is only done if the set life has a life of infinity. So if you set a life which is not infinity, there is zero overhead. You don't have any additional checks. And even when it's infinity, those additional checks are pretty insignificant compared to what a simulation graph of a particle usually does. So yeah, we don't expect this to have any negative side effects. It will just avoid most of the headaches and troubleshooting related to people just using set lives with infinite as the input instead of using the infinite life node. So that's about it. Also, while I'm on this simple effect, is it still? Yeah, infinite, okay. So while I'm on here, this is a good effect to showcase the next thing, because here I have only a single particle. And regarding the way that that PopcornFX handles memory and stores the particles, everything is pooled in batches, and by default the batches have 1024 particles capacity. So here on the summary tab, when you scroll down, you can see that for this layer, well, I have only a single layer here with one memory page with 1024 particles capacity, but I only have one particle. So the red parts here are the unused spaces. You don't actually see the green part. There is a super small green bar at the beginning because I only have one particle. But if I add a multiplier node, I'll set that to infinite, like 5 per second. I'll reset. So here you will see the green bar slowly increasing as more and more particles are added. So before 2.17 in the simulation hints, you had the storage size dropdown, which allowed you to set different page sizes. So here I just switched the page to 32 particles capacity. You had tiny, small, medium, large, whatever. So here 128 capacity. But these pages could not grow. So the default auto setting grows when necessary. But if you picked a tiny size, it could not grow, and this was problematic for the built-in nodes such as the event multipliers, because we noticed that in most effects, the vast majority of the memory wastage was due to event multipliers, because you typically have very few particles in these, and most of them would eat an entire 1024 page for a single particle. So now we changed the event multiplier to use the new setting in the preferred storage size, which is tiny growable. So it starts at the tiny size, but can grow to larger page sizes if you have a lot of instances in the scene and whatnot. So yeah, now 2.17, you automatically have nice memory savings because all the event multipliers in all your effects will automatically have smaller page sizes.
Is there a reason why not enabling that by default everywhere?
Yes, kind of, because we expect 32 capacity to be super low for most layers that consume time, and these having a tiny storage size would actually hurt performance because you have a small performance spike whenever the pages are resized. So ideally, for most layers, we want to pick a size that has a sweet spot between not too many resizes and a good initial size. So that's why we settled with 1024 initially, except that for the multiplier nodes specifically, you always have 1 or 2 out of 1024. So it was pretty bad. Yeah. So now it's much better in 2.17. And that's it for the runtime side. So I'll jump onto the editor specific features. So you might have noticed if you were using GPU simulation, that sometimes when you open effects, you had a pop-up with a progress bar that could take a lot of time if the effect was large and had a lot of layers using the GPU simulation. So here I'm going to show that in this effect, I will just switch the end layer to GPU, and I will pop the settings. And here in the effect editor settings, in the backend compiler section, I will force enable a few APIs, a few GPU APIs and the ISPC backend just to try to reproduce that and show you the issue. So here it's a very simple effect, so it won't be very visible. But now when I open it, you can see here that progress bar I was talking about. And so this is just a single layer. So imagine if you have like 10 layers, this could be pretty painful. So in 2.17, we added a cancel button. Yeah, that's the only change. So we did that because there were misclicks sometimes, and you realize that you didn't open the right effect, and you didn't want to wait like 4 minutes for the unskippable compile progress to finish. So anyway, it was annoying. So now you can cancel it, and you can see that because I canceled it, I have no simulation here. That's because it hasn't finished compiling everything. So if you still want to compile it, you can hit the compile button there, and it should resume the process, and now the effect runs. Also, something that was happening was that you could have done stuff that would have broken your effect, and no way of like opening the effect editor with the effect running and changing your graph, because as soon as the effect would run, the effect editor would like freeze or whatever. It shouldn't, but shit happens. Anyway, so now if you cancel it, you have the opportunity, because the effect doesn't run, to go in, edit your graph, disable some layers if you want. So a pretty minor change, but that can be useful in some cases. Also on the property grid size, I'd have to disable the, sorry, one sec. I will quickly disable all those backends. Oh, crap. Okay. Is that one?
Yeah.
It's been a while since we didn't have a live stream crash. Okay.
No bugs.
Right, so in the property grid, there is a new way to copy the values. So before you could only copy in a vector, copy component by component. Now we added a right click on the property name with copy component values, and you can now paste them in different components, in different properties, and it will just copy the entire float 3 or float 4 or whatever. So that's a pretty useful one. Now on the debugger side of things, small improvement. It's already really small stuff, but I'm still showing it. So here in this effect, I have a mesh renderer, which takes an orientation. And before, when you were debugging particles in the graph, you would have the orientations shown as the raw quaternion values. The debugger would just show the 4 floats in the internal representation of the orientations, which are quaternions. And yeah, you had basically no way to really understand what kind of orientation this was. So we switched this to display Euler angles in degrees, which is basically the same thing as in the property grid. The orientations, when you type them, it's expected to be the XYZ Euler angles in degrees. So this is the same format, just makes everything easier to read and understand when you're debugging particles. Also, the node graph, before 2.17, you had to explicitly save the view coordinates of the node graph. And sometimes, if nodes were moved, you would arrive in a layer and see nothing. And then you'd have to scroll and wonder where the nodes are. Oh, here they are. Or hit the Control-E button to frame all the nodes in the view. Now in 2.17, when you create a new layer, it will auto-fit the contents in the view. And for the layers that already have a saved view like this one, so if I hit Shift-E, I go back to the original saved view, you have this little button next to the capture view coordinates, which is clear view coordinates. So here I will clear them. And now whenever I open that layer, it auto-fits the view to fit all the nodes. So yeah, now no need to worry about where the nodes are. You will automatically see, at least in new layers, all the nodes whenever you open them. And in old layers, old graphs, sorry, I mean, if you want this behavior, you just have to clear the already saved view if you had an already saved view. Also in the settings, a little change there in the save and load. So before 2.17, save and load would only save and load the current page of the settings. So we've had some users give feedback that it was pretty annoying because they wanted to save a default user configuration for the entire VFX department for new people that arrive to just grab the default studio configuration. So they had to save each page individually. So now when you click Save As, you have this dialog with an option. You want to save all the settings or just this panel? So it's just an additional click to do, but yeah, it allows you to save all the settings, and then it's the regular thing. It will ask you where you want to save it. And same thing where when you want to load it, just load for all the settings or just this panel. So note here that you can save all the settings and then load just the current panel from the file that contains all the settings, if that makes sense. Also, we did the documentation pass on the built-in nodes. So for example, if I take the built-in event trigger node, you now have a description. Same thing for the pins. So the nodes and the pins did not have descriptions. The built-in nodes and pins did not have descriptions. So it's useful for some more obscure nodes, such as the generate node. A bunch of descriptions there. Anyway. And on the templates side and core library side, and I'm almost done, we added an additional scale input for some templates. So basically all the time templates, so self-age, effect DT, scene DT, scene time, all these now have a scale input. This is just because we noticed that in a lot of effects, people would just take the output and almost always scale the output by some value to do whatever with it afterwards. So now no more need for that. You can directly edit the scale here or expose it as a pin if you want to scale it by a custom value. It's the same principle as the VRAM node, where you have the scale here and allows you to scale the overall sphere produced by VRAM. And last thing, on the event triggering side, there was a kind of a naming inconsistency with the on death simple trigger ones, all that. So some of these were adding built-in payloads, some others did not. So we unified those names, and now basically you can use unspawn, undeath, trigger ones, and all these are the ones that take the predefined payloads, which are the ones you probably want to use most of the time. So yeah, a bit of a cleanup here. And all of them also take an orientation now, which wasn't the case before. And yeah, that's pretty much it on my side.
Yeah, right. So yeah, sorry for the sound issues, microphone incorrectly. We will save that setting for the future live streams now. So yeah, if you have any questions, let us know. Or as usual, you can find us on the Discord, and we'd be happy to answer any question you have. Yeah, I wrote the idea of when you mentioned to open an effect and cancel.
Yeah.
Being allowed to recover an effect would be nice to right-click an effect, open uncompiled, and
open without running the sim.
Yeah,
indeed, a right-click
to inspect the graph.
So we get feature IDs while doing the live stream.
Okay.
Uses Popcorn too much for a game called Trove. Oh yeah, well, Trove is actually using Popcorn v1. It's been quite a while since we heard anything from them. Yeah, it's an old v1 version. No node graph, just scripts.
Yeah, so Michael, you are asking any event to come, so I mentioned that at the beginning, but just to maybe there was too low of a volume. Let me check. Okay. Yes, so we'll be at SIGGRAPH 2023 this August on the French Pavilion booth. So it's Cap Digital. Basically, you will find the information on Discord soon. We will post the booth number soon. But yeah, we'll be there. So maybe nobody heard anything at the beginning. Nice.
All right. Okay. Well, thank you, everyone.
Thanks, everyone. And
don't forget to give us feedback on the Discord and to try out 2.17. Regarding the patches, we'll have the first patch of 2.17 next week. Then most likely the week after will be the 2.15 one and 2.16.6, the last 2.16.6 and 2.17.2, second patch. And after that, we'll see.
Yep.
Thanks, everyone.
Thanks. Bye.
Bye-bye.